We've already covered the introduction to the IA and then the exploration piece. We're going to go to the second of the major three sections, which be the analysis. It's worth 6 points. The exploration, analysis, and evaluation are all worth 6 points each. They're kind of the meat and potatoes of this. Again, we have this written down here. This is the actual rubric. And so if you look at it, it says the report includes sufficient relevant quantitative and qualitative raw data that could support a detailed and valid conclusion. So you need to have the data that you collected there. It needs to be appropriate, and then sufficient. Like you have to have enough data. So we're looking at 5x5s. There's so much that's not stated clearly that's within it. If you have fewer trials for whatever reason, you can definitely lose points. The second bullet, appropriate and sufficient data processing. This is when you do calculations. This is carried out with the accuracy required to enable the conclusion to. So you got to have the data that actually can show information about and make conclusions with it. If the data doesn't, then that's going to be bad. It's going to lose points as well. Third point, the report shows evidence of full and appropriate consideration of the impact of measurements uncertainties on the analysis. So we're going to do uncertainties of the equipment, which is random error. We're going to calculate uncertainties of process data. Those calculations would also be random errors based on the equipment. So it's a possible error. It doesn't say you have that error. It's a possible error. And then we're going to want to do some kind of precision analysis, which could be either standard deviation or using half range rule, since we don't have very many points. Five variation or 5 identical trials is not a lot. Also, if there's an accepted value, we can do a percent error, and then we go from there. So this is all about having the information, calculating the information so that in the evaluation piece, you can do just that. You can evaluate it. Without the data there, you can't evaluate it. The whole paper is very linear in the sense that as soon as you trip and fall, the rest of the paper is garbage. So if you don't have proper data and didn't process it properly, then you can't do an evaluation piece on it. So you lose so many points in the evaluation because you lost points in the analysis. So the last bullet, the process data is correctly interpreted so that a completely valid and detailed conclusion to the research question can be deduced. It's not deduced here, but data has to be processed and presented in a way that you can infer things. So we typically boil it down and then graph the last pieces. Typically, there's other documents that you can have. I'll send this to you if I haven't already. And this starts off with the very beginning, but here it says the explanation. What exploration? Achieving the mark, which is basically the rubric from IB. And then it kind of defines, like, what does that mean? How do you get these points? And it goes through how to get the points on the background, the appropriate methodology, environmental safety, etc. Now, the analysis. We've already gone through the rubric here that says how to achieve the mark. That's great, but how do you get those points? So you definitely want a qualitative data section. You need to explain what you're seeing, what you're looking at. You don't see chemical reactions as we write them on a piece of paper. You see color change, you see fizzing, you can feel heat being involved, or it gets colder. You can see it happening slowly, quickly, color change, change in physical state, change in, like, even the change within a state of, like, it was more of a powder, now it's more clumpy, things like that. So the qualitative section is going to be important. Quantitative should be obvious that we need this. So we're going to collect data and present it in a table form. The tables should have titles on the top. They should have listed exactly what you're measuring, the unit of measurement, and the uncertainty of the measurements. So then you have to process the data and overall uncertainties. So that's kind of what they're talking about. Sig figs are really important and being consistent throughout the tables. Calculations, every calculation you do, typically if you do one, you're doing 25 of them because you have a 5x5. And you usually need one sample calculation for those 25. And then you have another one. Even if you just subtract t final minus t initial, you do it 25 times and you need one sample calculation. It should be under a chart or a table like table 1, and it should say table 1, trial 1, or it doesn't matter, but you pick one, and then you type out the actual numbers with units and you type in the answer. When we calculate uncertainties, we need that. When you sum up and average all these on like a 6 table, you will have sample calculations for every different one. And again, uncertainties will deal with all that. So again, it's kind of tough looking at this error uncertainty. We want to classify, we'll need to classify it in the next section as random error, systematic error, qualify a number for each one based on uncertainty and things like that. To do that, you need to have this middle section done very well. Here's an example of one of my students a while back who did one. It is absorbance and had to do with breathalyzers. She did her own breathalyzer and looking at the different colors using a colorimeter. So this one's, she actually has a title at the bottom of the table. Kind of prefer the top, but it's fine. It's just she qualifies table 2 and then what table 2 is. And then time is in plus or minus 2 seconds. This is the whole thing is trial 1, and then you have the percents going across the top. It's a little unclear what the percents are. That could be done better. And also, yeah, so it's a decreasing percentage as it goes across, and then it's absorbance at periods of time. So trial 1, 2, and 3, 4, 5, and then typically you would average these together, sum them up. You would calculate overall uncertainties of the equipment, which is not a plus or minus of your actual data, just of the equipment. Here below, she has sample calculations to show exactly what each one is. Talking about the math, how to do it, put the numbers in. Then she goes and graphs each one of these separately. So the absorbance versus time. She has error bars involved. That's based on, those are not based on uncertainty of the equipment. Those are based on averages of numbers and using standard deviation or half range rule to come up with those. Everything's qualified as what the figure is or the table is or the graph is. It's a lot of data to crunch in this case. She's trying to do a linear regression for all these. Sometimes it fits better than others, and it's a lot. And then here is, again, she's kind of summing them up, boiling it down. So she had whatever she had, like 60 pieces per table and 5 tables, and now she's down to just 10 pieces or 11 pieces or 12 pieces. So more sample calculations, a final graph to show what the evidence is from this particular investigation. Set of data from a different investigation. And this is to show you that even though I kind of like the trials on the vertical axis, this they have the trials going across because the time is so many pieces. It would not work the other way around. So this is at 22 degrees plus or minus 0.01. That doesn't work because the 22 is 0.0 and the plus or minus is the 100th. They should be matching. Time to the apparently 8,000th of a second. It doesn't have to be exactly what you're doing. It just needs to make sense and be shown. So if you said it's good to the 10th of a second, that would have been fine. And then the masses are good to the thousandths because of the scale, the average mass per time, etc. They went through this. This is fairly convoluted on how they came up with the tables. And so sometimes data is hard to deal with and sometimes it's easier, but you need to do your best to make it simple. Messy and complicated, I know it looks good from a middle school perspective, but it's not. This needs to be a communication type piece. And you can see there are places where there's mistakes. So right here, this is a place where it needs to be to the thousandth, and there's one, and Excel just doesn't know sig fig, so you got to make it do it. And then more and more of the same. It's kind of messy. It's kind of hard to follow. but it may be just part of the data. But I think there's better ways and worse ways to do it. It looks like too many things on one graph. I don't really know what I'm looking at. They have multiple trials on one. If it's multiple trials of the same thing, we typically would average them and then make one table, sorry, one graph from the 5 trials. You don't need to graph each of the trials. So you typically average them out, come up with some kind of standard deviation or half range rule with it, use error bars, and make one line. Here's another investigation. You can see this table 1.2, table 1.3 says examining the effects of time under light at equivalence point volume. Now that's really confusing. They talk about the days. There's no plus or minus on these days. I don't think he did it exactly in 2 days, exactly in 4 days. So it needs to be a plus or minus. Even if it's not exactly what you say, you need to have it. So it needs to be like 2.0 days plus or minus, 1/6 of a day. So that's within 4-hour range or something like that. Also, I don't know what they're measuring. It's 37.4 and 35.9. I don't know. The uncertainty and percent uncertainty is, I guess, of the data above. Yeah, it should be. And so they have this part I'm not upset about. They have an average. They have the uncertainty of that average. These sig figs should match. So if the uncertainty, well, honestly, it has 1.6. So if you took this out of here, you'd have 3.36 plus or minus 2 is what it should be. And percent uncertainties, because they're percents, I usually like 2 sig figs. The first one tells you the place value that you're uncertain, and the second one just shows you the fraction of that place value. The third one's kind of pointless. More sample calculations, that's fine, that's good. Graphing, do not connect the dots. Don't ever connect the dots. You're either going to try to make a linear regression, some kind of exponential expression, but connecting the dots makes no sense whatsoever. Pictures, I love it. Shows what you're looking at. It shows more information. It's showing a qualitative data section, and this is a graph that we started off with to figure out where it was being absorbed. This will help out with the personal engagement, not just look up the actual absorption wavelength, but actually look at this. And since it's being absorbed way in this purple area, we would like to measure that area. Or it's slightly absorbed in the red, but mostly the purple. So this shows how you're picking your numbers, and again, helps get that second point. Here's the data. Apparently it's a variation of temperature. So the first one is 10 degrees plus or minus 1. The volumes, I don't know of what exactly, but that would be kind of helpful to have that. Absorption doesn't have any units, so that makes sense. The place values are all good. They calculate the rates. The rates are all to 3 sig figs. Then they have an average and then a half range. So the average, because the half range is to the thousandth, then the average needs to be rounded to the thousandth. So that's good. And they do that for each and every one of these. So all these data points are boiled down to a single average rate. Sample calculations. The uncertainty of the equipment, it would be random. You can speak to this in the next section, but that's fine. It tells you how you do the calculations. And then graphing at the different temperatures with the uncertainty shown in half range rule, in the error bars, which they did half range. So looking at this, also, you could try to make it linear. They actually made it slightly curved, the best fit line. So that's what you typically do. You boil it down, your 25 points are boiled down to 5 points, and then you graph those 5 points with uncertainties, typically an error bar, because as you can see, they're different depending on the trial. The first 10 degrees, there's quite a bit variation. 30 degrees, very little. Back at 70, quite a bit. So those are things you can discuss and talk about in the next section.